Welcome to E-Pathashala lecture series for MArch students. The main topic is sustainability and green building material. In this we are going to look at embodied energy of different building materials, embodied energy of different building materials and low energy building in the industries. In the last session we have seen extent about LCA and LCEA, that is life cycle analysis and life cycle energy analysis. Here we are looking at embodied energy. What is the difference between LCA and the embodied energy? LCA, which integrates or represents a cradle to grave of an life cycle of the materials, whereas embodied energy, it is the total energy which is required for the extraction of the material, processing this material, manufacturing the materials and delivering these materials to the site. That is nothing but cradle to grave life cycle analysis is LCA, cradle to grave energy analysis is nothing but it is called embodied energy. In a short nutshell, embodied energy is the energy used in the buildings. It can be energy consumptions like which produces carbon dioxide, again it contributes the greenhouse gas emissions which again lead to the depletion of the ozone layers. So, we need to cut down these consumption of these carbon dioxide emissions in the buildings, which is again an indicator for the overall environmental impact rating for the usage of building materials and systems in the industries. Embodied energy, many people will have a wrong thought. It is available energy or it is the energy it is produced. People always refer it as energy available or inherent in a product. For example, the energy recovered by burning a product, it can be also called as cumulative energy demand, that is nothing but the sum of the energy which is inputted in the product system for the energy. But embodied energy, these kind of understanding of energy inputs and the product system, it is not correct. It is nothing but it is a electricity generations which is connected to a distribution network and also to the high voltage national grid. The manufacturing process which included in the embodied energy, for example, if we look at the processing of the timber right from cutting down the tree and removing the parts of the wood and the woods into various required sizes, and these sizes of the wood it undergoes to a various seasoning and it can be used in the manufacturing of the doors, usage of construction of the doors and the windows, which has much higher embodied energy when compared to a country wood locally used by a vernacular buildings. And the energy which is employed in new constructions, it always increases 10% in every year, which we have seen in the life cycle analysis, and also it is similar in terms of the embodied energy. More or less 50% it goes into the production of the material and also 50% which goes in terms of the transportations. The various elements involved in embodied energy, that is electricity which is delivered to the site and energy losses in terms of productions, that is nothing but converting this materials in terms of fuel nearly 60 to 70% which can be consumed, other percentage it goes into the wastage. Similarly, the transportation and I repeat transmission and the distribution losses is nothing but fuel extraction, processing and the delivery. The various elements of the embodied energy, the processing, the heat, transport, feedstock. Feedstock is the fuel which is used in the situation where they are not directly oxidized, such as oil and gases in the plastics, the carbon in the cokes and so on. And energy in terms of capital equipment. This analysis of embodied energy in Danish and Netherlands. We have already seen in LCEA, life cycle energy analysis. Again we are looking at in terms of embodied energy of these building materials in terms of energy consumptions. See, if you look at it, the energy consumptions of the material which goes higher value is of energy usage is plastics, and the lesser value in terms of concrete, and the next it comes under to the brick, and the hierarchy goes on to the steel and various finishes inside the materials like glasses, paints. It also comes under to the range of about 500 to 600. And if you look at it in the Syrah 95, it comes around at the value of about 158 and other indigenous or imported materials. And if you look at plaster boards, it comes around 167 to 220. In the wet process, it gives a value of 174. In the dry process of the material, it gives 106. With the several recommendations, we can identify the proper embodied energy of the materials and identifying the appropriate materials used in the building materials with the in terms of lesser energy productions. So, now the question arises to us when we have seen the previous chart of Danish and then other one. So, we have a question in our mind, that is, how do we reduce this embodied energy? These embodied energy conceptions in the manufacturing to the implementation, it is on a greater value. What are the steps or what are the indications we can reduce this environmental impact of these materials? Most of these building materials which also plays a vital role in creating the environmental impacts in the initial processing stage. What are the ways to reduce this embodied energy? Now, let us account 20% of the building materials that is using this embodied energy use. So, embodied energy can significantly reduce the overall environmental impact of the materials. If we reduce 20% itself, it gives a greater impact in the environment. Embodied energy can be considered over the lifespan of the building in many situations. We have seen in the LCA the examples 60 years of a building, how much is the energy depletions and energy analyzed in the buildings. Similarly, higher embodied energy materials or a system can be justified in terms of reducing the operating systems. For example, a durable material with a long lifespan such as aluminum, it can be the appropriate material in terms of selection, but if you look at it in terms of embodied energy, it is higher in terms of embodied energy. That is the operational cost, the manufacturing cost of this material, which includes higher percentage. So, embodied energy is a measure which quantifies the non-renewable energy per unit of a building material, component or a system. I repeat, it is a measurement for the quantity of non-renewable energy. Renewable energy which can be produced and again and again. Non-renewable energy which is produced once cannot be recycled at all. It is something like only the operation, it goes directly. There is nothing like take back policy in the embodied energy. It is expressed in terms of megajoules or gigajoules in terms of energy consumptions, or in terms of weightage like kilogram or ton, or in terms of the always it represent in terms of a square meter in the process of calculations. And embodied energy is a complex and involves numerous sources of data for the any simple materials. Now, look at this chart. These are various materials which is used in the building industries and the energy coefficient of the materials in terms of megajoule per kilogram, and for 1 cubic meter usage of this material, how much energy coefficient we are consuming it in terms of megajoule per meter cube is in the second graph. I'll read out the contents inside this chart like calcium carbonate, cellulose pulp, cement, ceramic, concrete, earth, insulation, paper, plaster, timber, water. All these materials, as we know that it is used in the building industries. The lesser value, if you look at it in terms of timber, 3.1, and the more lesser value is 0.22 for earth. If we use the earth, it gives a very lesser energy value. Less than 0.22, there is another component we have as a clay. If we use clay, it gives a much reduction in terms of energy usage. It is 0.1, it gives a value. Rammed earth also 0.73 in terms of megajoule per kilogram. Concrete 1.4. Ceramic, it gives a higher value of about a range of about 7.7 to 5.7. 10.4 goes only for the usage of cement and fiber cement boards. So, if we use stainless steel, other materials like steel in terms of structural components, which gives a range of about 35 to 50. So, in this chart we can understand that with various building materials, the steel plays a higher in terms of megajoules per kilogram, that is in terms of consumption. Next is ceramic material, and also in terms of usage of binding material like cement. The lesser materials we have seen is the clay or the cement, that is a rammed soiled cement, and timber also to an extent of about 3.1. Now, look at the value in terms of per cubic meter of usage of these materials. It will be similar only. For clay, again it gives 45 gigajoules or megajoules per meter cube. Earth straw is 360, and again the higher goes into a value of 3,95,540, 2,81,820 in terms of energy usage in the building. The next it comes under the cement, 20,280 megajoule per meter cube of energy it is used, and ceramic materials also like 13,880 and 12,830 megajoules per kilogram or per cubic meter. And timber, if you look at the value is more or less it shows a very constant factor of about 1000 to 3000 or 4000 is the value it goes into the value, and the higher is like 3 lakhs to 2 lakhs it is the steel, and all the earthen materials it ranges from starting minimum from 40 and goes up to a range of about 2000, and concrete 2000 to 3000, and ceramic 13,000 to 12,000 range it goes on, and cement it plays on higher value of about starting from 1000 it goes up to 17,550. So, with this analysis, this table of energy coefficient, we understand very clearly usage of earthen material, that is nothing but the vernacular materials available in the site, and provides greater energy consumptions, that is reducing the energy coefficients and embodied energy reductions, which gives a good social environment or good community to the sustainability, and the life cycle energy analysis of the material also, which provides a higher value, which again imports a healthy living environment. Usage of materials like man-made factors like cement and galvanizing the materials, refracting these materials like polishing it, ceramic materials which gives a higher values, and the amount of usage of steels, though it may gives more of recycling process, but the energy imported in that and the embodied energy associated with in terms of steel and concrete, which provides a higher value in terms of emission of gaseous substances and also in terms of recycling value and a lesser content. Lightweight materials will reduce lower embodied energy than heavyweight materials, but in some situations lightweight construction also will result in a higher energy usage. For example, to heat any surface, we require the overall energy like air conditioning unit, all this operational energy which provides higher in terms of the value. When selecting the building materials, their embodied energy should be considered with respect to the durability of the building materials, that is lifespan of the building materials, the quality associated with in terms of greater extent, and how easily these materials can be available, and these materials can be separated. The materials can be used by locally, and these materials can be recycled in constructions, and by specifying the various standard sizes of the materials and to minimize the waste. This is the main factor in construction industries. If we avoid the waste, more or less 10 to 12% we are consuming the energy, and selecting the appropriate materials which is manufactured using renewable energy resources plays a vital role in terms of reducing the embodied energy. Now, look at this graph. It is similar to the life cycle analysis we have seen already. That is, we are going to look at the input and the output of the materials. The input, if you look at it, other factors like energy, we have virgin resources. Virgin resources is the naturally available materials. They are like, for example, if you are quarrying it from the stone from the mountain or a clay from a earth, similarly that is nothing but the virgin, that is the material which is available in the site. And recycled resources, it is need not to be a virgin resources, it can be from anywhere and we can use it in the materials, building industries. So, these are three factors which is considered as an input in the cycle. Output, if you look at it, water polluting substances, emissions in the air, it is the globally the atmosphere is also taking part into the output. The solid waste treatments, discharge of the materials waste and the recycling of these materials. So, first is the extraction of the natural resources. It is similar in the life cycle analysis also we have seen. Transportation of these materials, production of these materials from the site, or either it is from the manufacturing from the companies, and from the manufacturing unit again it goes to the transportation part, so that it goes to various dealerships, various showrooms for the people can choose the materials and can use it in the buildings, and the transportation of these materials to the various outlets. These manufacturing products again it goes into the distribution of these materials into the various places, and consumption of these materials and utilization of the materials, and again it goes to the transportation which goes to the site for the constructions, and then recycling, that is after 60 years the materials, whatever the left out materials in the buildings which can be recycled, and this can be transported again or it can be disposed by the municipal waste and everything. This is a typical product systems which is used in a life cycle assessment, and we have seen the embodied energy associated with the in terms of life cycle assessment in input and the output. In the input we have seen energy, virgin resources and the recycled, and the output water, emissions in the air, solid waste and the recycle treatment. And reducing this embodied energy by selection of appropriate materials and analyzing the durability, that is the strength of the building material, that is passive building materials to a sustainable construction, and use of locally available materials and using the recycled materials in a well efficient manner will reduce the embodied energy, and standardizing the sizes in the constructions and to minimize the amount of waste. In this way, we can reduce the embodied energy. In the embodied energy, we can see various aspects of analysis in terms of design in architecture and also the material usages, the manufacturing part of it, and the distribution percentage, and assembly on site and in use 83 percentage, refurbishment and demolition. In this pie chart, if we look at it, the light blue, that is 83 percentage, which goes into the credits of the manufacturing of the materials or the usage of the materials, that is maroon, the red color which indicates the material or the product, that is the manufacturing of the product, which goes into a percentage of about 15 percentage, and the distribution of this material, it goes to 1 percentage, and the assembly on the site, that is in demarcated in a purple of violet color, it is in 1 percentage, and other percentage like demolition, if you look at it, is 0.4. So, usage of the material which credits major percentage in terms of energy, that is nothing but 83 percentage, and next comes to the 15 percentage for the manufacturing thing. Here we can understand that in design aspects and the other analysis plays a very minimal role in terms of energy of embodied. The material production and the assembling of these materials, usage of this material categorized to a greater extent in terms of executions. Similar graph, if we look at it, for example, the usage of various materials in the embodied energy, which we have seen already in terms of megajoules per meter cube and then gigajoules per meter cube. But here we represent it in terms of the usage of the gigajoules. If you look at it in current building industries, like various materials we have seen like plaster, stone, clay, mud, ceramics, concrete, plastics, timber, copper, aluminum, stainless steel. In this widely used material is one is steel, which is higher in terms of embodied energy, and plastic to one into all consumer products and also in the building industries in terms of furnitures and other interior furnishing materials. It also comes under between 100 to 150 embodied energy, and the next comes is the major one, which is there is no substitute in terms of replacement of the techniques, the concrete, which categorize about 200 to 220 embodied energy, which plays a very higher value in terms of energy usages and in terms of production and in terms of executions. Next comes to the masonry part, either it can be stone masonry or rubble masonry or random rubble, coarse rubble. It comes between to the value between 50 to 100. And other minimal values goes only for the stone, because it is excavated from the site and then dressed it and then used with the binder. The ceramics also plays quite a good number in terms of embodied energy. If you look at it, it is 50 to 100. So, in this chart we understand that steel, concrete and plastic, they are the major elements which is used in the building industry, which is also have higher embodied energy. Now, we look at the examples of energy usages in USA. 5023 megajoules which is used in per square meter. Among this pie chart, if you look at it, the construction which is represented in the pie chart here, and site work which is represented here, site work is 9 percentage and doors are represented 20%. Finishes is represented here. The finishes categorized to an higher value of 27.27%, and equipment HVAC also to an higher extent. Concrete is shown in a complete representation of hatch like this, black patches. So, hence we will understand that not only the concrete plays a higher embodied energy, here in terms of energies it goes in terms of finishes and the interior elements. We will see a next chart which give the entire picture very clearly. So, here the various representation of interior elements chart is given here. The blue color, it is the partitions which is used inside the buildings, and the red which is used in terms of interior doors, it is given 3%, and the wall finishes, various wall finishes in terms of cladding of tiles or using wallpaper or by using panelings, it is categorized about 7%. Floor finishes, it goes to a major extent of about 25% here. The floor finishes can be a marble, granite or ceramic or by vitrified files. And then we have ceiling finishes. Ceiling finishes again we can go for a plaster of Paris or gypsum board finishes. This also comes under the value of about 10% here. And the movable furnishings like carpets, draperies and curtains and all these things comes around 8% in terms of energy. And mobile furnishing like workstations used in the office spaces, that comes around to the value of about 13%, and staircases, the materials used in the staircases in terms of cladding and then finishing or the polishing of it. So, thus we understand that interior partitions and flooring of inside the building material which has higher embodied energy and other factors and all which is very less. The major percentage is again goes for ceramic, 21.5% in the buildings, and the usage of steel in the building comes around a value closer to 26%, and next comes the cement factor is 11.7%, and lime very minimal content like 3%, the mortar binding material is 9%, gravel used in the materials building is 3.5%, prefabricated concrete is 2%. So, aluminum is 7.7%, additive is 4% and wood is 1.5%, PVC is 1.9%. So, thus we understand that ceramic, steel and cement plays a major higher value in terms of energy or embodied energy used in the buildings. This is a report which is generated by Center for Research for Energy Resources in Spain. Thus, we understand the usage of various building materials and their inputs in terms of embodied energy. In a short nutshell, we will look at US energy consumption by sector. In US, the 43% which goes into the building operation and the 6% which goes into building construction and materials, and 23% which goes for the industries and 28% which goes into transportations. Here we can understand that the materials, when they transport from manufacturing to the site, 28% of wastage of fuel is generated, and from the industries to the building operation it takes about 43%. Thus, we select locally available materials, we can reduce these factors and we can have building operations in a such a way, if we increasing the life cycle and energy of the material, we can have the recycling cost also cutting down. I repeat, we can increase the building operation by energy consumptions and reducing the wastages and increasing the recycling material in the building, we can increase the operation percentage. Report by US energy consumption by sector. Thank you.